found difficult again was I to the power of 40. Okay, so again here we're going to try and pull out the I to the power of 4 wherever possible, because that's just equal to 1. So I'm just going to rewrite this one as I to the power of 4 times 10. Okay, so using my rules from my log tables, I know that I can write that out as I to the power of 4 all to the power of 10. Okay, so those are our indices rules in our log tables, and I know then that I to the power of 4 using what I've written up here is equal to 1. Okay, so 1 multiplied by itself 10 times is just 1. So I to the power of 40 is equal to 1. Okay, and then this one says simplify 2 plus 3i over 1 minus 2i, giving your answer in this form. So we're just going to be writing it as a complex number again. So remember, a complex number is a real part and an imaginary part. So b times I just means that we're going to have something multiplying by an I. So I have 2 plus 3i over 1 minus 2i. Okay, now remember, if I had something like, let's say 6 plus 9i, and I was dividing it by 3, that would be nice and easy, because I could do 6 divided by 3 and my 9i could divide by 3, and I'd literally just be left with 2 plus 3i. Here it's not so easy, because the bottom, the denominator, contains an imaginary part. So how do I get a complex number to end up being a real number? So if it was a real number, for example here I just had 3 without the imaginary part, how could I get that here being a real number? So remember, when we multiply by the complex conjugate, we end up of a complex number, we end up with a real number. Okay, so I'm going to multiply by the complex conjugate here. So I want to multiply that denominator by its complex conjugate. So I want to multiply that by 1 plus 2i. So remember, the complex conjugate is when we change the sign of the imaginary part. Now, if I multiply the denominator by that, I need to also multiply the numerator by that. Okay? So I have here, so just to say why that's the case, so if I had something like a half, okay, and I said, oh, well, I want the denominator to be 6, I could multiply the bottom by 3 to get to 6, and then if I do that, I have to multiply the top by 3, and I would get that 3 over 6, which was the same as what I started with, a half. Okay, so that's what I'm doing here. If I wanted to multiply the bottom by the complex conjugate, I need to multiply the top by the complex conjugate as well. Okay, so I'm going to do that out now. So I have, 2. So the first bracket on the top needs to multiply by everything in the first bracket everything in the second bracket on the top. So 2 times 1 is going to give me 2. Then I have 2 times plus 2i, which is going to give me plus 4i. Okay, then I'm going to have the second thing in the first bracket. So plus 3i by 1 is going to just give me plus 3i. Then I need to multiply the second thing in the first bracket by the second thing in the second bracket. So 3i by plus 2i is plus 6i squared. Okay, and then that was all over, and I need to multiply out the bottom now. So I'll multiply 1 by 1 to get 1. Then 1 by plus 2 to get plus 2i. Then the hardest part about this is me choosing my colours. Minus 2i by plus I is minus 2i. And then, let's see this green. Minus 2i by plus 2i gives me minus 4i squared. Okay, so I want to go and simplify this out. So on the top line, I have 2. There's no other real numbers there, so I'll just write down 2. Then I have a plus 4i plus 3i, so that's plus 7i. And then I have my plus 6i squared. Okay, and that's all going to be over, and I'm going to simplify the bottom. So I have 1, and then I have a plus 2i minus 2i, which is just going to be cancelling. Okay, and then, so I have 1, and then minus 4i squared. Okay? So now what I realise is, okay, well, I know that I squared is the same as minus 1. So I'm going to fill in, instead of the way that I squareds are, I'm going to fill in minus 1. So I'll have plus 6 times minus 1. And likewise on the bottom, I have 1 minus 4 times a minus 1. Okay, so when I multiply those out, so I'll get 2 plus 7i minus 6 over 1 plus 4. Okay, so I'm going to just simplify the top here, because I know 2 minus 6 is minus 4. So I'm going to minus 4 plus 7i, and then on the denominator I have 1 plus 4, which is 5. Okay, so I have minus 4 plus 7i equals 5. And I can write this as well as minus 4 over 5 plus 7i over 5, or 7 over 5i. Okay? Okay, I'll stop that and then go on to the next one.